Have you ever pondered about the mysterious black holes that lurk in the corners of the universe? These celestial anomalies known as black holes are a fascinating subject of space exploration. Born from the remnants of massive stars after they collapse under their own gravity, black holes are regions in space where gravity is so strong that nothing can escape from it, not even light. At the heart of a black hole is its singularity, a point where matter is believed to be infinitely dense. Surrounding this singularity is the event horizon, the point of no return, beyond which anything that crosses it is swallowed whole. Black holes warp the fabric of spacetime to such an extent that inside the event horizon all directions lead towards the singularity. Black holes are not just space vacuums, they are extreme cosmic phenomena that challenge our understanding of the universe. In essence, black holes are the universe's ultimate enigma, a space where time and space warp to their extreme. Ever wondered how rockets defy gravity to soar into the cosmos? Well, it all comes down to a concept you might already be familiar with: Newton's third law of motion. You know, the one that states, for every action there's an equal and opposite reaction. When a rocket shoots gas out of its engines, the gas goes down, the rocket goes up. That's the action and reaction at work. Inside the rocket engine, a process known as combustion takes place. Fuel and oxygen combine and ignite, producing a high-pressure and high-temperature gas. This gas is expelled through a nozzle, creating the force needed to lift the rocket skyward. But it's not just a one-shot deal. Rockets launch in stages. The first stage, or booster, gets the rocket off the ground. Once its fuel is depleted, it detaches, and the next stage takes over, pushing the rocket further into space. Rocket science, once unraveled, is a testament to human ingenuity and our unending quest to explore the universe. What if I told you that most of the universe is made up of something we can't see or touch? Well, that's exactly the case with dark matter. This elusive substance is believed to make up approximately 85% of the universe's mass, yet it neither emits nor absorbs light, making it virtually invisible to our current detection methods. Despite its elusive nature, dark matter's existence is inferred through its gravitational effects on visible matter, like stars and galaxies. It's the invisible glue that holds galaxies together and prevents them from flying apart. Scientists across the globe are tirelessly researching this mysterious entity, using cutting-edge technologies and theories. Some believe dark matter consists of undiscovered subatomic particles, while others propose modifications to the laws of gravity to explain its effects. The search for dark matter is one of the most exciting quests in science today, pushing the boundaries of our knowledge and comprehension. Dark matter remains one of the most intriguing puzzles in our understanding of the cosmos. Can you fathom just how vast the universe is? It's a question that has baffled thinkers for millennia. The universe isn't just big, it's incomprehensibly enormous. It's so vast that we often use the term observable universe because there's a limit to how far we can see. This limit is defined not by our technology, but by the speed of light in the age of the universe. Now, let's talk galaxies. Each galaxy, like our own Milky Way, is a sprawling city of stars. There are estimated to be around 2 trillion galaxies in the observable universe. That's a 2 followed by 12 zeros. And each galaxy contains hundreds of billions of stars. Remember, these numbers represent just the observable universe. The actual universe could be much, much larger, perhaps even infinite. It's a humbling thought, isn't it? Our universe is a vast expanse of mysteries waiting to be uncovered. Imagine needing to go to the bathroom, but you're floating in zero gravity. Now that's a predicament. But fear not, astronauts have it all figured out. In space, the usual pull of gravity isn't there to help things along, so using the bathroom gets a bit tricky. The International Space Station employs specially designed systems to address this. For number one, astronauts use a device that works like a vacuum cleaner, sucking away the liquid. For number two, they sit on a specially designed toilet seat that uses airflow to keep everything in place. This waste is then compacted and stored for disposal back on Earth. But it's not all business. The process of cleaning oneself is also a bit different. Wet towels are used for bathing and the air system helps to dry them off. So space or not, our astronauts know how to keep things tidy. Even in space, nature's call doesn't wait. What happens when a star dies in a spectacular explosion? Picture this: a colossal burst of energy, so immense that it can outshine an entire galaxy. This is a supernova, a stellar explosion marking a star's dramatic end. The birth of a supernova begins with a star of considerable size. As the star burns through its nuclear fuel, there comes a point when the pressure from the nuclear reactions can no longer counterbalance the star's own gravity. The core collapses under its weight, triggering a shock wave that catapults the outer layers into space. These celestial fireworks play a crucial role in the cosmic scheme of things. They enrich the universe with heavier elements like gold and uranium, scattering them across the cosmos. Some of these elements eventually coalesce to form new stars and planets, perhaps even life. Supernovas are the universe's grand fireworks, signaling the end of a star's life cycle. Their death throes, as catastrophic as they may be, breathe life into the universe. How did it all start? What sparked the creation of the universe? These are questions that have intrigued humanity for centuries. Enter the Big Bang Theory, an explanation that has significantly shaped our understanding of the cosmos. The Big Bang Theory proposes that the universe began as a hot, dense point nearly 14 billion years ago. In an instant, this singularity expanded exponentially, giving rise to space, time, and matter as we know them. This theory is supported by various lines of evidence, including the observed redshift of distant galaxies and the existence of cosmic microwave background radiation. However, the Big Bang Theory is not an explanation of the why, but rather the how. It doesn't speculate on what caused the initial singularity or what existed before it. Instead, it provides a framework to understand the evolution and current state of the universe. The Big Bang Theory gives us a glimpse into the birth of our ever-expanding universe. How do astronauts catch some shut-eye while floating in space? Imagine trying to sleep while weightless, surrounded by a symphony of humming machines and blinking lights. That's the nightly reality for astronauts in space. The absence of gravity means they can't just lay down on a bed. Instead, they sleep in specially designed sleeping bags that are strapped to the wall of their spacecraft. These sleeping quarters are compact, but they provide a sense of privacy and some shielding from the ongoing noise. Even so, astronauts commonly report having lighter, shorter sleep periods than on Earth. This is due to a combination of factors, including the absence of natural day-night cycles and the physical discomfort of floating. To overcome these difficulties, astronauts maintain strict sleep schedules and often use sleep aids. They also use specially designed eye masks and earplugs to block out the ambient light and sound. Sleeping in space might sound dreamy, but it comes with its own set of unique challenges. What's left after a supernova explosion, a marvel called a neutron star? These celestial bodies are the remnants of massive stars that have undergone a dramatic explosion. But don't let their small size fool you. They pack a punch, with a mass about 1.4 times that of our sun, all squeezed into a sphere with a diameter of about 20 kilometers. How can so much mass fit into such a small space, you ask? The answer lies in their name. Neutron stars are made almost entirely of neutrons, particles that have no electric charge, allowing them to be packed incredibly closely together. This makes neutron stars the densest objects in the universe, save for black holes. A sugar cube-sized amount of neutron star material would weigh about as much as a mountain. These stars are not only incredibly dense but also boast powerful magnetic fields and can spin at incredible speeds. Neutron stars, the universe's densest objects, are yet another wonder in our cosmic backyard. How do we know so much about the planets circling our sun? Let's delve into the methods that have allowed us to unlock the secrets of our celestial neighbors. Our journey begins with the telescope, a groundbreaking invention that first gave us a glimpse beyond our own planet. Over centuries, telescopes have evolved, allowing us to observe the planets with unprecedented detail. But to truly explore the planets, we needed to get closer. Enter space probes. These unmanned spacecraft have visited every planet in our solar system, from the scorching surface of Mercury to the icy realms of Neptune. They've mapped surfaces, analyzed atmospheres, and even landed on some planets. Meanwhile, in the field of astronomy, the study of light waves has unveiled the composition of these distant worlds. Through spectroscopy, astronomers can determine what elements make up a planet's atmosphere, or even its surface, all from millions of miles away. Our understanding of the planets in our solar system is a testament to our curiosity and our technological advancements.